Okay, so what I have here on the left side of the screen is a basic text editor. What I have here on the right side of the screen is a terminal. Everything's going to be exactly the same as long as you use G++ to compile your programs, no matter if you're on Mac, Windows, or on a Linux operating system. So the very first thing we're going to do here is cover comments. This is a comment. Just like many other languages, you can create a comment just by putting 2 dashes and then whatever you want. And if you want a multi-line comment, you can just type in multi-line and then close that off. So there is commenting in C++. First thing we're going to do here is include some outside libraries. We're going to have some functions that we're going to want to use. So this one's going to allow us to use a function called cout and a whole bunch of other different things you're going to see here in a second. That'll be used for vectors. This will be used for strings, and then this will be used for file I/O. Now all of your code is going to be contained inside of a main function like this, and then you're going to have a curly bracket, and then you're going to have a closing curly bracket. Now inside of here, you could call the function cout either using cout or std cout, like this. What I want to do is get rid of this part, and how I get rid of that is right here, right after the include statements. I'm going to type in using namespace st. And that's going to keep me from having to type that out every single time. Now if you wanted to do a basic hello world type of statement here, all we're going to have to do is type in hello world using cout, which outputs the text that we have here, and a carriage return whenever we type in the same brackets you see right there, and end L. That's for the carriage return, and this right here is saying we want to output this on our screen. The other thing we need to do here is call return 0. You're always going to do this, and 0 stands for the execution went through perfectly fine. So just to keep everything simple. Jump over here in the terminal, and this is the command I'm going to use to run this. It's called ctut, and make sure with your C++ programs you always end them with CPP as the extension. And then right here I'm saying that I want to use the version 11 of C++. Then I'm going to compile that, and then to run it I'm going to put /a.out. And if you're on Windows, you would just type in A, and you can see hello world prints out right like that. So the next thing we want to discuss here are variables and data types. Now variables start with a letter and can contain, of course, additional letters, numbers, or underscores, but they must start off with a letter. And here we're going to actually create a constant variable, which is going to be of type, data type, double, which means that it contains floating point numbers or decimal places. And here we're going to give it the value of 3.1415926 535. And once again, constant being here just means that this value cannot be changed, and normally whenever you define constant variables you make their names in all uppercases. Other data types that are available to you are characters, which contain just one character, and they are going to be surrounded by single quotes. So let's say I have a grade equal to and A, right like that, and there you go. And a character very specifically is going to take up 1 byte inside of memory. Booleans, which normally start with is whenever you're defining the variable name, can contain true, which is going to be comparable to 1, or false, which is going to be comparable to 0. Ints or integers are just whole numbers without decimal places. Floats are floating point numbers just like doubles, and they normally are accurate up to 6 decimal places. Let's just say favorite number and just copy this guy. And doubles, of course, like I said before, are also floating point numbers, but they tend to be accurate up to around 15 digits in length. And then of course if I want to output one of these variables on the screen, I'm going to use cout again, and then I could say favorite number inside of double quotes, and then to output it I just put another bracket inside of there, favnum, and then of course end L for a carriage return, and there you can see favorite number 3.14159. Now, of course, there are other data types that are available. We have short ints, which are going to be at least 16 bits in size, long ints, which are going to be at least 32 bits, long ints that are going to be at least 64, unsigned ints, which are going to be the same size as the signed version, and long doubles, which are not less in size than regular old doubles. If you want to find out the number of bytes for a data type, we could come in here and go cout and say something like size of int. We could then call up size of and put my age inside of there since it is an int. And inside of C++, all statements end with a semicolon, so we could just jump down here, keep everything on the screen, and go like that. Compile and execute. You can see right here size of an int is 4 bytes. If I would then go in and do exactly the same things for characters, booleans, floats, and doubles, and execute, and you can see how many bytes are in each one of those as well. If you're wondering how big a number can be based off of bytes and so forth and so on, let's go in here and let's create the largest int that we can possibly create. And whenever we know the fact how many bytes an int can contain, we can then go in and define exactly how large that number would be. And you can see right here, this is the biggest integer we could possibly have. And if we went down here and said, hey, let's go and output that like this, and you can see it prints out exactly the way that you would expect it to. However, if we go 1 over and put an 8 in there instead, and save that, and recompile, you're going to see that you get completely different results. See, it comes back as a negative number. That's just a demonstration of what happens whenever you go outside of the bounds using your different data types. When it comes to arithmetic, you're going to be able to use plus and minus and multiplication and division, as well as modulus, which is going to return the remainder of a division. We're also going to be able to use shorthand incremental notation as well as decremental. Give you an example of what that looks like. You can see right there on your screen, and exactly how you would perform addition if you wanted to output that on the screen like this. And to demonstrate the shortcuts for increments and decrements, let's say that we have an int, and I'm just going to call it 5 and give it the value of 5. Then output on our screen, 5 plus plus is equal to, and then take the variable 5 and increment it. I'll then increment it from the left side, and then I'll decrement it from the right side, and then I will decrement it from the left side. And you can see what's going on right here. In this situation, whenever you increment from the right side, it is going to actually perform that action after it gets the current value of 5. That's the reason why you see 5 here. Then over here, whenever you increment it on the left side, it is going to increment it first. Remember, it currently has a value of 6 because that's what happened up here, and that's the reason why you get a 7 over here. And likewise, whenever you have decrement on the right side, it occurs after the value is taken here. And then here you see that both of them are decremented, and we're back at 5 again. We'd also be able to come in here and use another form of shorthand assignment notation by going 5 plus or equal to, and let's say 5 in this situation. That right there is going to be equivalent to if you had 5 is equal to 5 plus 5, right like that. Or let's change this into 6 so it's not quite so confusing. And yes, you could put multiple statements here on the same line just as long as you have semicolons. That's how C++ defines that a statement has ended. Another thing that's important is to understand order of operation, in which basically it states that if you have some calculation that's being performed, the multiplication and division are going to be performed before any addition or subtraction. And you can see right here exactly what we're doing. Here I have braces around the additions and subtractions, and up here I do not. And here if I execute, you can see I get dramatically different results. Why is that? Well, in this situation, we are going to have the multiplication occur first. That's where you're going to get 6 right here. Then we're going to jump in and have this add up to 3, which comes to -3. In this situation, we're going to perform addition and subtraction first, which is going to give you a value of 0. So when that's multiplied times 2, you're going to get 0. So use braces all the time. It's going to save you a lot of hassle. Now let's say we come in here and we want to show some division here on our screen. And this is exactly how we would do that. 4 divided by 5. However, if we execute that, we might not get the result we were looking for, which in this situation comes out to 0. What happens whenever we want to actually show a floating point number here with decimal places instead of basically just coming out to 0? It's actually very simple. Just come in here and we're going to perform what is called casting. To cast from any of the different data types, you're going to take the type that you want to cast to, put it between these parentheses, and you can see here, we now compile and execute, you're going to get exactly what you wanted. And of course, these can be performed by putting int inside of here to cast to an integer, even though that's exactly what it is, characters, as well as doubles, right like that. Now you can get rid of all this stuff here so that we can focus in on the if statement. Now the if statement is just basically going to execute different code depending upon different conditions. You're going to have comparison operators, which are going to be equal to, not equal to, greater than, less than, greater than or equal to, or less than and equal to. You're also going to have logical operators, which are going to be and, or not. And they're going to come in the form of and, or not. So let's go and take a look at some examples of how we could use these. Let's say that we create an age which is equal to 70 years old, and another age at last exam. Let's say we want to set up a little program here that is going to define if a person is going to be able to drive or not. And then we're going to have is not intoxicated, and we're going to set that to true. Always a good thing if you're going to drive. Now we're going to come in here with our if statements. We're going to say something like if the age is greater than or equal to 1 and There's the logical operator. Make sure you close all the brackets off the right way. Age is less than 16 in this situation. Well, in that situation, we're going to say that they cannot drive. Now, if we want to check another condition, we're just going to type in else if. And in this situation, let's check to see if they're intoxicated. In this situation, we're going to use the not symbol, and we're going to say is not intoxicated. And all that's going to do is take this true right here, the not in this situation, and turn it into false. And in that situation, we're going to say you can't drive again. I could also come in here and do an even more convoluted thing. If, and it could say something like age is greater than or equal to 80, and then do another completely different comparison. Age is greater than 100, or, more brackets here, age minus age at last exam, and then close that off, greater than 5, and then close these off. So what I'm basically saying here is if the person is over the age of 100, we're not going to allow them to drive. If they are going to be over the age of 80 or equal to, we're basically going to require them to take an exam every 5 years to verify that they are actually still able to drive. It's kind of a convoluted example, but I'm just trying to find a reason to be able to come in here and show you how all these different things work. And in that situation, we're going to say that they can't drive. And then finally, for everything else that isn't checked, if we want them to have the ability to drive, if they make it the whole way down here, we're going to just type in else. And there you go. You're going to see that that works for you. And here, if we execute it, you're going to see that yes, indeed, this person can drive. So that's a pretty convoluted example of how to use if statements, as well as else and else if. Now let's take a look at the switch statement, which is basically going to be used whenever you have a limited number of possible options. So let's say we have int greeting option, and let's say they chose 2. Then what we're going to be able to do is check the versions or the values of greeting option with our switch statement, put it inside of curly brackets again. Then we're going to say case if the value of greeting option is equal to 1, well then we're going to say that we want to print out on the screen bonjour. Then to jump out of the switch statement altogether, we're going to type in break, and if you didn't check that, it's going to continue to check all of the other possible values, like it will jump down here if you don't have break inside and check to see if it has the value of 2. So you want to make sure the break's in there. And you could have hola and all those other different options. And then finally, with the switch statement, if you want to have a default thing that it's going to do, if none of the other things match, you just type in default and then cout and hello, right like that. Don't need break here in this situation. And you can see based off the fact that they did enter a 2 here, that hola prints out on the screen. That's basically everything you need to know about the switch statement. Now we'll take a look at the term.